Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving deep into a fascinating area, developing AI agents for system engineering within the game Factorio. It might sound niche, but the implications for AI, and even our understanding of intelligence, are actually pretty broad.
Yeah, I agree. Factorio is a surprisingly complex environment. You've got resource management, logistics, production chains. It's a real engineering challenge, even for humans. So, seeing AI tackle it is definitely interesting.
Interesting, definitely, but I'm also a bit skeptical. Aren't most of these Factorio AI agents just glorified deep learning models trained on massive data sets? Is it really telling us anything new about intelligence, or are we just brute forcing our way to solutions?
I think there's some truth to that, Sarah. It feels a lot like throwing computational power at the problem and hoping something sticks. The real challenge, I think, is getting AI to understand the relationships within Factorio, the spatial arrangements of factories, the temporal flow of resources. Deep learning often struggles with that kind of thing.
Exactly. And that's where I think this topic gets really interesting. We're seeing some research that's trying to move beyond just brute force deep learning. They're looking at things like hierarchical planning, modular architectures, stuff that's actually inspired by how the brain works.
Okay, but I think we need to give deep learning its due. Look at AlphaGo, AlphaZero. They mastered incredibly complex games using primarily deep learning. Isn't it possible that with enough data and compute, we can just scale up those techniques to handle Factorio and eventually even more complex real-world engineering problems? You see these massive models trained on everything under the sun. They're starting to understand the world around us, right?
But understanding is the key word there. Do they really understand, or are they just extremely good at pattern matching? I think deep learning excels at finding correlations, but it often fails at grasping causation. A Factorio AI might learn that placing a certain building near another building leads to increased production. But does it actually understand why that happens? Can it reason about alternative layouts or adapt to unexpected resource constraints based on that understanding?
And that's where the spatiotemporal reasoning comes in. It's not just about recognizing patterns. It's about understanding how those patterns evolve over time and how they relate to each other spatially. Imagine AI that can not only build a factory, but also anticipate bottlenecks, optimize resource flow based on predicted future demand, and even redesign the factory layout on the fly based on changing circumstances. That requires a deeper level of understanding than just recognizing patterns. I think we're very far from that with current deep learning.
Okay, I see your point about spatiotemporal reasoning, but isn't it possible that deep learning can eventually learn those relationships? With things like recurrent neural networks and transformers, we're already seeing models that can handle sequential data and capture long-range dependencies. Maybe it's just a matter of scaling them up and training them on even more data from Factorio simulations to capture that temporal and spatial understanding.
I think the challenge is in the efficiency of learning. The brain is incredibly efficient at learning complex relationships, often with very little data. Deep learning, on the other hand, requires massive data sets and huge amounts of computation. And even then, it can be brittle and prone to overfitting. It's like learning to ride a bike by watching millions of hours of bike riding footage. You might eventually figure it out, but it's not the most efficient way to learn. Maybe, if we try to start with the minimal required components to perform reasoning. Instead of relying on massive datasets, we can find an easier way to intelligence. What do you think about that less is more in Limo?
Exactly. That's why I'm more interested in neuro-symbolic approaches. These combine the strengths of neural networks with symbolic reasoning. You can use neural networks to learn perceptual features from the game environment, but then use symbolic reasoning to make decisions based on those features. For example, the AI can learn to recognize different types of buildings and resources using a neural network, but then use a set of rules to decide how to allocate resources based on the current state of the factory.
And the symbolic representation allows for explicit reasoning about the why. The AI doesn't just know that X leads to Y, it knows why X leads to Y. That understanding allows it to adapt to new situations and make more informed decisions. In a world with blueprints, the location is explicitly important.
But haven't neuro-symbolic approaches struggled to scale to complex problems? They can be good for relatively simple domains, but when you start dealing with the sheer complexity of Factorio, with its thousands of interconnected components, the symbolic representation can become unwieldy and the reasoning process can become computationally intractable. It feels like the symbolic nature of neuro-symbolic is really just symbolic constraint. Symbolic systems are not great at dealing with noisy systems. Neural systems are and can make quick associations.
That's a valid point. Scaling is definitely a challenge for neuro-symbolic approaches, but I think there are ways to address that. One is to use hierarchical representations. You can break down the problem into smaller, more manageable subproblems, and then use symbolic reasoning to solve each subproblem independently. Another approach is to use modular architectures, where different modules are responsible for different aspects of the reasoning process. The same modularity and layered representations that the neocortex does.
Yes, and you can also use neural networks to guide the symbolic reasoning process. For example, you can use a neural network to learn which rules are most relevant in a given situation, and then use those rules to make decisions. That can help to reduce the search space and make the reasoning process more efficient. I think there's a lot of potential in combining the strengths of both approaches. So, a more traditional JoFi approach might still be possible, but it needs the fuzzy decision-making of neural networks.
I think the key is finding the right level of abstraction. You don't want to represent every single detail of the game world symbolically, but you also don't want to just rely on raw sensory input. You need to find a way to represent the relevant information in a way that allows the AI to reason about the world effectively. This also goes to spatiotemporal reasoning. Abstraction-object relations over space and time.
So, are there any specific examples of research that are taking this kind of hybrid approach to Factorio AI? I'm curious to see how these ideas are being implemented in practice.
There are a few projects exploring the use of reinforcement learning with symbolic planning in Factorio. The AI learns a basic set of actions through reinforcement learning, but then uses symbolic planning to combine those actions into more complex strategies. It's still early days, but the results are promising. The problem with reinforcement learning as it currently stands is that it needs too much training data to deal with the curse of dimensionality. We can use all the knowledge of the game engine and the coordinate system to build an AI agent, but that all feels like it needs to be coded by a person.
I've seen some work that uses graph neural networks to represent the factory layout and then uses symbolic reasoning to optimize the flow of resources through the factory. The graph neural network allows the AI to capture the spatial relationships between different buildings, while the symbolic reasoning allows it to make informed decisions about resource allocation. I think the spatial location is very underappreciated and can be used to build coordinate maps, as Donald said.
Yeah, and I've been thinking about how we can represent different coordinate systems within the AI. Imagine an AI that can seamlessly switch between world coordinates, blueprint coordinates, and even abstract representations of the production flow. That would allow it to reason about the factory at different levels of detail and make more informed decisions about design and optimization. So, a factory's design should be transferable into a different factory system.
Okay, that sounds interesting, but isn't that just feature engineering? I mean, you're essentially handcrafting features that you think are important for the AI to learn. Isn't the whole point of deep learning that it can learn these features automatically from the data?
Well, yes and no. Deep learning can learn features automatically, but it doesn't necessarily learn the right features. By incorporating some prior knowledge about the domain, we can help the AI to focus on the most relevant information and learn more efficiently. It's like giving the AI a head start. You could potentially even use AI to generate the relevant features, based on all the knowledge of the game engine.
And it's not just about feature engineering. It's about building AI systems that are more interpretable and explainable. Deep learning models are often black boxes, making it difficult to understand why they make certain decisions. With neuro-symbolic approaches, we can actually see the rules that the AI is using to reason about the world. I think that's crucial for building trust in AI systems, especially when they're being used to make important decisions.
Exactly. If the AI tells me it's going to redesign my factory layout, I want to know why. I want to understand the reasoning behind its decision, so I can be sure that it's actually making a good choice. And knowing why also allows for better training. It allows for understanding the system.
Okay, I'm starting to see the appeal of these hybrid approaches, but I'm still not convinced that they're going to be able to outperform pure deep learning models in the long run. Deep learning is advancing so rapidly, and with the increasing availability of data and compute, it seems like it's only a matter of time before it can solve even the most complex reasoning problems. I am, however, curious about that less is more approach. It kind of goes against everything that I believe currently.
I think it's more about finding the right balance. Deep learning is great for certain tasks, like perception and pattern recognition. But for tasks that require reasoning and planning, it might be beneficial to incorporate symbolic representations and reasoning mechanisms. It's about using the right tool for the right job. It's all about the right architecture.
And I think the key is to focus on building AI systems that are not just good at solving problems, but also good at learning and adapting. Deep learning models can be very brittle and prone to overfitting, while neurosymbolic systems can be more robust and adaptable. It's about building AI that can learn from its mistakes and generalize to new situations.
And I think that's where the spatiotemporal reasoning comes in again. If the AI can understand how the world changes over time and how different objects relate to each other spatially, it can be much more adaptable and resilient to unexpected events. The ability to switch between coordinate systems is likely to be key to adaptation.
So, what are some specific research directions that you think are most promising in this area?
I'm really interested in exploring the use of neuro-inspired architectures for Factorio AI. I think we can learn a lot from how the brain represents and processes information, and we can use those insights to design more efficient and robust AI systems. I want to see how the brain handles errors, since that seems to be something the AI has troubles with. Can it model its own performance to improve itself?
I think we need to focus on developing better neuro-symbolic algorithms that can scale to complex problems. I want to see more research on hierarchical reasoning, modular architectures, and the use of neural networks to guide symbolic reasoning. How can we build AI that will work even on less capable hardware, that has a minimum viable memory footprint?
I think we need to develop a core algorithm that's capable of manipulating spatiotemporal relationships across different domains. I want to see more research on how to represent different coordinate systems within AI and how to translate between those systems seamlessly. How can we encode that into neural networks, or how can we use AI to generate this core algorithm?
I'm still a believer in the power of deep learning, so I want to see more research on how to scale up deep learning models to handle the complexity of Factorio. I want to see more research on recurrent neural networks, transformers, and other techniques that can capture temporal and spatial dependencies. How can we increase the computational efficiency of the algorithm? And what is the performance gain from increasing the training set?
It's clear that there's no single answer to the question of how to build AI agents for system engineering in Factorio. It's a complex problem that requires a multifaceted approach. But by combining the strengths of different techniques, we can hopefully make significant progress in the years to come. It might also lead to advancements that we can use in the real world.
And I think that the lessons we learn from building AI agents for Factorio can be applied to a wide range of other domains, from robotics to manufacturing to urban planning. It really does feel like the right direction. How can we use neural networks to help with system engineering to make the perfect layout and manufacturing pipeline?
Absolutely. Understanding how to build AI that can reason about space and time is crucial for building truly intelligent machines that can interact with the world in a meaningful way. It seems likely that it will move the needle forward in terms of actual AGI. I want to be able to ask it to build anything, and it should understand how to reason about what I am asking and tell me if it is something that is possible.
Yeah, even if deep learning is the final answer, it's still valuable to explore these alternative approaches. They can help us to better understand the limitations of deep learning and to identify new research directions. And if nothing else, these techniques may be useful in other AI applications. This is all truly exciting news.
Well, that brings us to the end of today's discussion. Thanks for joining us on Cognitive Spirals. We hope you found this exploration of AI and Factorio insightful. Until next time, keep those neural circuits firing.